Unit 2, Homework 1, Notes. Expressions can be used to represent quantities when those quantities are a sum of other values. When they are unknown values in the sum, variables are used. Expressions with variables raised to a power are often written in a standard way. This allows expressions to be more easily compared. Polynomials, or expressions, can be added and subtracted like real numbers. Adding and subtracting polynomials is a way to simplify expressions and find a different but equivalent way to represent a sum or difference. A factor is one of two or more numbers or expressions that when multiplied produce a given product. For example, in the expression 2a, 2 and a are each factor. An exponential expression is an expression that contains a base raised to a power or exponent. For example, a squared is an exponential expression. A is the base and 2 is the power. A polynomial is an expression that contains variables and or numeric quantities, where the variables are raised to the integer powers greater than or equal to 0. The degree of a polynomial is the greatest exponent of the variable. A polynomial function is a function written in the following form. And guys, I know this looks really strange and ugly, but don't worry about it. That's just standard mathematics garble. Where a sub 1 is a rational number and a sub n does not equal 0. That means over here we don't have a leading coefficient of 0. And n is a non-negative integer. That means we're talking about the counting numbers and the highest degree of the polynomial. Classification by degree. Guys, you're going to have to write this down in your notes somewhere. Okay, we're going to talk about the highest exponent. We're going to classify it by the exponents. Okay, if there is no variable, that means the exponent is 0. Okay, and our function would look like f of x equals 2, and this is called a constant. Okay, if our highest exponent is 1, okay, our polynomial would look something like this. This is a function of x, and it's called linear. Okay, if our exponent, our highest exponent is 2, right, look like that. F of x equals 2. And we call this a quadratic. If the exponent, highest exponent is 3, we call this cubic. If it's 4, we call it quartic. Remember quarts? 5, it's quintic, and it can go on from there. Now, like terms are terms that contain the same variables raised to the same power. For example, the terms 2a cubed and negative 9a cubed are like terms since each contain the variable a raised to the third power. When two polynomials are added, the result is another polynomial. Since the sum of two polynomials is a polynomial, the group of polynomials is closed under the operation of addition. A system is closed or shows closure under an operation if the result of the operation is within the system. Are whole numbers closed under addition? Yes. No matter how you add, you will always have a number that is in the set of whole numbers. Is whole numbers closed under subtraction? No. For example, 2 minus 3 is equal to negative 1, and negative 1 is not in the set of whole numbers. Classification by terms. We're going to classify our polynomials by terms. If we have one term, that would look like this. Our function would look like that. We call this a monomial. If we have two terms, function would look like this. It would be a binomial. If we have three terms, this is a trinomial. If it was a function, it would look like this. Remember now the f of x part over here, okay, that's like saying y. The polynomial part is over here. Okay, and if we have 4 or more terms, it's just a generic polynomial. The leading coefficient of a polynomial is, hold it, let me get rid of that guy. If the leading coefficient of a polynomial is the coefficient of the term with the leading coefficient of a polynomial is the coefficient of the term with the highest power. For example, in the polynomial expression, 4x to the 5th power plus 9x to the 4th power plus 3x plus 12, the term with the highest power is 4x to the 5th power, therefore the leading coefficient is 4. Example 1, identify the terms in the expression negative 2x to the 8th power plus 3x squared minus x plus 11. I want to make very sure that y'all understand that this is in standard form, okay? And that means descending order of exponents, okay? And this polynomial here, negative 2x to the 8th power plus 3x squared minus x plus 11 is in descending order, okay? My coefficients, okay, I have coefficient here, oops. Okay, my coefficient is negative 2. I can't get that little negative to show up. Okay. 3x, not 3x squared. Okay. Negative 1. And 11. Okay. My variable, x to the 8th, x squared, okay, x, and there is none on the constant. Okay, the powers, I have power of 8, power of 2, power of 1, and no power at all. Example 2, subtraction. We can rewrite any subtraction using addition. So we can rewrite this problem here as plus or negative 2x to the 8th power plus 3x squared plus negative x plus 11. So for our example here, we're going to simplify, which means we are going to take this negative sign between the two polynomials and we are going to distribute it into the first one, right? So that we have this rewritten as an addition problem. We're going to collect like terms, and negative x cubed plus negative 10x cubed is negative 11x cubed. All right, and then we have negative 3x squared and 4x squared, and that's going to come together and be 1x squared. We have 20 plus negative 9, which gives me 11, and I didn't have anything over here to do with this x to the, or 6x to the 4th power, so it's just comes on down. If you notice, I have this written in standard form, okay, which means it's a 4th degree quartic, meaning 4, and I have 4 terms, so this means it's a polynomial. Now, let's define exactly what a polynomial is. Polynomial has no negative exponents. Polynomial has no fraction exponents. Polynomial has no variables in the denominator, and it has no variables under radical. As long as these are not being, you have none of these situations here, and you've got variables going on, you have a polynomial.